Good evening. So today we are going to see the basic atomic, what we can say, I can't say this as a structure. It is all about atoms. We are going to see. Okay. So first of all, you must know what is an atomic number. What is an atomic number?
It is the number of proton or electron.
So what is an atomic number? You can say once again. What is an atomic number?
Number of protons plus neutrons.
Atomic number is number of protons alone. Okay, number of protons or number of neutrons. Why we call this R? Why we call this
Both
R?
are same number.
Both are in same number, right? Then what is the charge of an atom based on this? Atom consists of both protons and electrons in equal number. So what is the charge of a proton?
Positive.
Positive charge. What is the charge of an electron?
Negative.
So since it is equal in number, what is the charge of an atom?
Neutral.
Very good. So the charge of an atom is neutral. What is the charge of neutron?
Nothing.
No charge. Very good. So you need to say no charge. Okay? So this atomic number is designated by letter Z. What is it called? Z or Z. So it is designated by letter. So then mass number. So mass number is designated by letter A. So children will confuse with this. Since it starts from atomic number A, they used to do this letter as A, atomic number. Okay. The thing is not like that. We are in a globalized education system. So as per the globalized education system, the atomic number is designated by letter Z, mass number by E. Understood? So then, what is the mass number? Number of protons plus,
Number of neutron.
I'm using very basic English. I think it is understandable by the children. Okay, so plus number of electrons or neutrons?
Neutrons.
So what about this? We usually call this as number of nucleons.
The number of protons and neutrons are
Present in the
Like
nucleus. Present in the nucleus. So it is overall the proton, nucleons are nothing but number of protons and neutrons. Okay? It is situated in the nucleus. That means how the atomic structure will be, that is the correct structure. So protons and neutrons embedded to form a spherical shape, and then it is situated at the center of the atom. So it is known as nucleus. If you remove proton or proton or neutron from that, definitely there is no nucleus. Like a bundi forming laddu, it is embedded to form a shape of sphere. It is already there. It is formed first. Actually, our research is going on beyond. Okay, if you divide an atom, if you see inside an atom, that is protons and neutrons. If you see inside proton, there are so many baryons, kryptons, and everything. All the particles are in. If you see so many elementary particles, you can see. Okay. See, for example, you are considering atom. Atom is a microscopic level. So it is in microscopic level. What is the size of an atom? You can imagine 10 power minus 11 to 10 power minus 15 meter. It's very, very small. What is 10 power minus 3 meter? What is 10 power minus 3 meter?
1 by 10,000.
Die. What is it called? In your scale, it is graduated, right? What is 10 power minus 3 meter? Millimeter.
Yes.
You can find the graduation in your scale. What is that millimeter? You know. That distance, you know, right? If you divide that millimeter graduation into 2, then one part of that is 10 power minus 6. So that is micrometer. Understood or not? Very, very small. See, in between. First, you are taking a scale. half a meter scale or 1 meter scale. That 1 meter is divided into centimeters. In between 1 centimeter, you can see the graduation of millimeter. So in between millimeter, you can see the graduation of micrometer. In micrometer, you can see the graduation of nanometer. Likewise, it is going on, going on, going on. If it is 10 power minus 12, it is picometer. It is 10 power minus 15, it is Fermi level, Fermi meter, Fermi level only. Atomic size is Fermi level. That is unimaginable size. Even we need a precise electron microscope to see the structure of an atom. Understood? So that atom is, suppose if you see into an atom, then you may find nucleus, protons and neutrons. Then if you see into a proton or neutron, then what? All elementary particles. Okay, I don't want to confuse with you in this part, since you are very young enough. You can learn until this particle. So what are the subatomic particles? This is usually we used to call the subatomic particles. There are so many elementary particles, bosons, baryons, so many things are there. Okay, mesons, okay, pions, everything have found already. But it is not recorded in your book. In your book it is very basic things are given. So highly outdated things are given. Okay, but that is important for learning. That's the basic. Okay. So now we will get into this portion. So first of all, you must know about the atoms. So what is the letter designated for an atomic number? Z. What is the letter designated for mass number? So what is A minus Z? What it gives? Guess.
Mass number minus atomic number.
Yeah, guess.
Equal to-
I told you this. So from this, what is the mass number? Number of protons plus number of neutrons. What is the resultant?
Number of neutron.
So if you subtract A minus C, then that is number of neutrons. Likewise, you can easily find the number of neutrons. 1929 only Chadwick found neutron. Very recent calculations. Okay. So is it clear for you this? Then what we can see? Next one. So the isotopes. You must know. First, atoms you know. There are isotopes also. So what is an isotope? You must understand. What is an isotope?
Atoms of same element having same atomic number with different mass different mass number.
Yeah, isotope. Yes, atoms of same atomic number or same element, you can say. Atoms of same element. So you must understand what is an element. Same element with same atomic number but differ.
Different mass number.
Yeah, but differ in mass number or different mass number. Okay, understood? So these isotopes are found in Earth. You may think hydrogen, it's diatomic, right? You may think like that. Hydrogen exists in diatomic nature. But how does hydrogen exist in nature, in our atmosphere? So hydrogen maybe exists in the terms of all these things. Like this only it can exist. So this is actually speaking, it is protein. It's named as. What is its atomic number? What is its mass number? Basically, an element is designated by a letter here. So most probably this is atomic number, this is mass number, or you may represent an element like this, either this way or this way. Okay, so you can write like this or like this. Like this also you can write. Clear? So it is known as protium. This is known as deuterium. then this is known as tritium. Understood? So protium, deuterium and tritium. Okay,
TM.
TM.
AD.
That is named by the scientist. So I told you, no, on those days, maximum the name is given by the scientist. The scientists, you know, they are from the Middle East countries, European countries, maximum. Okay, so or Hebrew people, Latin people, Greek people, they used to keep their names like that. Okay, so you don't confuse with that. Then there is a story for that. Mendeleev periodic table, modern periodic table, you must understand. You have to understand the elements. So from that, this IUM name, everything, it is coming from that periodic table. So maximum Mendeleev kept that table. Kept that name. Okay, that is very interesting story. We'll learn about that later. Now we'll come into the valency first. Then we'll learn about this periodic table. Okay, so how the periodic table arises from Dobberner to modern periodic table was constructed, and then now it is in practice by Moore. Dr. Moore, yes. Okay, so we'll see. So this is protium, deuterium and tritium. How about this one? See the atomic number, how it is for all. Same. What is the mass number?
That is
Different. Right or not? So you can say, what is the number of neutron in protium? What is the number of neutron in protium? 1 now. How can we find the number of neutron?
A minus.
What is that for the protium?
A minus.
What is it?
What is for protium? Make it fast.
Mass number.
What is for protium?
0.
So what is the neutron number?
Yeah.
It is 0.
0.
So what is for deuterium? What is for deuterium?
1.
What is for tritium?
2. 1.
Like this. Okay. It is existing in nature. Actually speaking, this is at 93%, approximately I am saying. So it says about the abundancy of the element. So this is 93% means 93% of our Earth's atmosphere consists of protium alone. Understood? Only 5% consists of this deuterium. 2% consists of tritium. This is all about the abundancy of the element. I am just giving approximate value. We will see this atomic mass unit in the upcoming classes. Atomic mass unit, molar concept and everything. That is in the basic. So, atomic mass unit and molar concepts in the next class. We'll see. Okay, so right now you must understand these are the isotopes. So now coming to the point valency, we need to learn. Okay, so this is nothing but what is an isotopes, you know, right? Is it clear? There are isobars also. What is an isobar? Take a note. Isobar. BAR. Atoms of different elements. Atoms of different elements. This is very important. On the isotopes, you saw only
Same.
all the hydrogen atoms. Likewise, all chlorine atoms. Chlorine also has isotopes. Carbon also has isotopes. So many elements having its own isotopes. It is not existing in the earth like carbon. If carbon means, what did you learn from the periodic table? What is the atomic number? What is the mass number?
6 and 12.
6 and 12. Very good. So 6 and 12 you have learned, right? 6 is the atomic number, 12 is the mass number. But you don't think so the carbon should contain that. That is the original carbon. There are so many types of carbons. The average is working out, and the average is said to be the atomic mass unit. That we'll discuss that later. Okay? So don't think the elements present in this particular periodic table, it is existing in the nature like that. Okay? So there are so many things has to be clarified for you. I'll explain you in the next video. So what is this? Atoms of different elements having same mass number but different atomic number. Same mass number but different atomic number. Okay. See, while writing mass number, you have to write along with this A. While writing atomic number, you can write along with this Z. Always make sure you have to write all these things. So it will fix in your mind. So next one, what is that? Isotone. See how many elements are present in the air. Isotones are atoms of same or different elements. So it's an assignment for you. You have to Google it and find the examples for isobar, isotones, and so many examples for isotopes also. Okay. So this is isotone. What is an isotone? Different elements or same elements having?
Both same or both different?
Yeah. Both means not both. Any three atoms can also be like that. So all the atoms may be same or it might be different. Okay. So which is having same
Mass and
neutron number. Neutron number alone same. Neutron number means you know A minus Z. You have to find all A minus Z from the particular isotopes. Then you will be able to see all the numbers. Neutron numbers are same for this elements. Okay. This is very specific elements we can say, atoms we can say. Okay. This iso means it is having some unique identity in it. Okay. It's having something common. So that is isotope, isobar and isotones. These are all present in the particular periodic table. Okay. So why we are able to find the valency of that particular atoms or elements? What is the necessary for finding the valency? Because what is valency? What is valency now? What is valency? Yeah, the number of electrons present in the outermost,
So we are having 4 shells.
present in the outermost shell. Why? What is this shell? What are the other names for this shell?
A shell, L shell, M shell, and N shell.
So you are used to call this as energy shell, right? Or you can use to call this as orbit, right? If it is an orbit, so for example, this is a nucleus. Electrons are revolving in a orbit like this. Okay, see here you can find an electron. You will find an electron. Understood? So electrons are revolving around it in a various orbits. Okay, so what I am trying to say, orbit means what is an orbit? Is there any other path over there? It's an imaginary. The scientists, they just come out their observations with their own understanding so that it can be able to understand by a layman. If he is a scientist, he can able to understand everything. How he can express it? Then only others can understand what it is going on, right? So he expressed everything. Like, so it's an imaginary path. Okay, ma? So Bohr plays a vital role on it. Bohr only explained all about this orbit. Okay, why he used this energy shell for it? This name. Since electrons are revolving around it, right? So it is in motion. Suppose if an object is in motion, what are all the energies associated with it?
The type of shell.
Kinetic energy and potential energy. Okay. So what are the energies? Both the energies always associated with an object. The energy possessed by an object by virtue of its motion is kinetic energy. If you find anything, right from the microscopic to celestial, if you find anything which is in motion, it is definitely associated with the energy. That energy is known as kinetic. If you find a particle here, there, here, which is associated with gravity, So that is potential energy. Okay. So in a space there is a cavity. I mean gravity we can say. The space is a maximum we can say it's a garment like. The space is a garment like. So in it there are gravities. So why there is different gravities between planet to planet? That is a very vast story. We'll discuss about that later. That's really interesting. Okay. Right now, see from the atomic structure we are going to the celestial objects. Okay. We can apply it also. In nature there is a symmetry. Okay. You are also created by atoms. That is named as cells. Right. For living things we used to call that as cell. All building blocks. Okay. Now we are coming to point energy shell. So it is associated with kinetic energy. Do you agree with me? Okay. It is in motion, right? Always it is in motion. Unless otherwise it can't stay in an orbit or it can't stay with an atom. Understood? So energy shell. So what are all the energy shells you have learned? K shell,
KLMN.
K shell, L shell, M shell, N shell. Right. These are all the energies. I mean, these are all the energy levels. Actually, it is known as principal quantum number. Why we call this as quantum number means you can't take any one atom out of one material. It is impossible. So you can take a sample, an amount, a quantity, a quanta of atoms like that you can take. Okay, so that quanta of things you are taking, right? So it deals with quantum mechanics. Before Einstein period is the very golden period. Before Einstein, everything was thought like it is classical. Classical mechanics deals with single particle. Or you have to consider electron as a particle, photon as a particle, or proton as a particle. Okay, corpuscular theory. Newton taught maximum corpuscular theory. Based on Newton's corpuscular theory only, Einstein began his work. Then what happened? Then at the final, after integrated with Planck's lab or experiments, he came to know there is a wave nature for a particle. Okay, Huygens also involved. So many scientists. So they did a very lot, things for a society. Okay, so from that they came to know it is a wave nature. The particle behaves like a wave nature. So there, what he suggested, we have to take a quanta of photons, quanta of energies, or quanta of atoms. We can't able to separate one atom or one electron. So that he considered everything as quantum. So he derived a number. So this is quantum number. There are 4 quantum numbers. Principal, azimuthal, or orbital. Okay, first you write a definition for orbit. The path followed by an electron around the nucleus, or imaginary path you can write. Imaginary path followed by an electron around the nucleus. Okay? It is derived from principal quantum number. So the principal quantum number is designated by letter n. If n is equal to 1, k shell. N is equal to 2, L shell. N is equal to 3, M shell. N is equal to 4, L shell. It goes on like that. Clear? Then next point you can write the maximum number of electrons in each and every orbit is 2n square. The maximum number of electrons in each and every orbital is orbit is 2n square. Okay? So try to understand. For our own understanding, what the people will do, they just draw an orbital like this. I'll explain you. Say for example, so this is the first orbit. Okay. This is nucleus. This is first orbit. Then second orbit. Then third orbit. It goes on like that. Fourth orbit, like that. Okay. So it is, I mean, for our convenience, they just constructed like a circular orbit. Okay. Sommerfeld came and then he derived, it's not a circular orbit, it's an elliptical orbit, which is a replica of our solar system. Okay. After Kepler prediction over all the solar system, so they came to know about this elliptical orbit also. So there is a connection between a small microscopic atom to a big celestial objects. That's what. Some symmetry is maintained. Okay. Then what about K-shell? I told you, no. What is the maximum number of electrons in each and every orbit? 2n square. Can you find the number of electrons in K-shell? What is that? Yeah, 2 into 1 square. In the place of n, you have to substitute 1. So that is principal quantum number. Okay. So that is equal to 2. Then 2 into 2 square. That is equal to 4. Then 2 into 3 square. That is equal to 8.
18.
Here,
18.
then
32.
it goes on like that. Okay. First orbit 2. Second orbit 8 electrons can be accommodated. Third orbit 18 electrons can be accommodated. It is not like, for example, there must be 2 electron, there must be 8 electron, not like that. It is the maximum occupancy of the orbit. Suppose what is the maximum occupancy of this class? If 10 students are occupied with this particular class, then that is the maximum occupancy. That means less number of students also can be occupied, not the more number. So it should not exceed, the number of electrons should not exceed this number. That's all. Okay. Then, so this is number of electrons in an orbit. You must understand about orbital also. Put heading as orbital. I hope you have copied this. Should I rub this thing? So I will explain you about orbital. This thing definitely you must understand. Unless otherwise you can't do with this. In schools and all, maximum, I am not talking about every school. In some of the schools, they are not giving very clarified idea or detail about this balancing. Okay. Then put a heading as orbital. Orbital is the probability of finding an electron in an orbit, or we can say it is sublevel. Okay, I'll explain you this with the diagram. I'll be coming to that. So it is actually derived by a quantum number called azimuthal quantum number. Azimuthal or orbital quantum number. So it is designated by letter L. There, what is the letter for principal quantum number? N. Ma'am is telling you how to tell.
Lots பார்க்கறது.
Keep everything in your mind. Don't behave like a grandma syndrome. Okay? Your memory should be sharpened. If I am asking you something about from Korean web series, then everything in your mind. Their names. Okay? So that is your level of interest. I am not criticizing that. You can have, but that kind of interest you should show in your learning, studies, right? So this is azimuthal quantum number, orbital quantum number. There are so many sub-levels. So the S level, P level, D level, F level. Only this thing you are going to learn in your schooling stage. Okay. If you are taking chemistry as your major, then you have to learn more levels. So the very interesting facts are behind this. Okay, I'll explain. Okay. Then we'll see this. What is S level? Okay. See what I have told, orbital. Orbital means, what is an orbital? What is an orbital? Sublevel.
The probability of
Finding an electron. So this is a sublevel. Okay, so that means you know in the first orbit it is having only one sublevel. I'll explain you in such a way that it is having only one sublevel. That means you can find how many number of electrons can be occupied? Two. So one can find in this particular level, another can find in this particular level. For example, I am saying this is the probability of finding an electron. It can be here, wherever it might be. It can be here also, right? So this is said to be the probability of finding an electron. Okay? So first level it consists of only one sublevel. So that is named as S level. See, in S level, I will explain you how the electrons are revolving around that, nucleus, by spinning also. So not like our Earth is revolving around the sun by rotating about itself also. It is rotating about itself so that we are experiencing day and night. It is rotating by itself in its own axis as well as it revolves around the sun with different axes, right? So two different axes it is performing its own rotation and revolution, right? The same way, electrons also, it is moving like this. You can imagine this as the nucleus. Okay, this as the nucleus. Electrons are revolving in it by spinning and then moving like this. So it moves plus of rotation minus, like a vibration you can be able to judge in such a way. It is just an energy. Okay, if you just show a torch, it spreads light energy. Can you see that? Spreads light energy. Like a way, it's a kind of energy. So plus of rotation, minus of rotation, plus of rotation, minus of, plus of, minus of, plus of, minus of. So it is able to spin. It is known as spin. So the spin of an electron is due to first plus of rotation, next minus of, like that. Okay. So that two electrons can be accommodated. This also you can write. The maximum number of electrons in each and every orbitals is equal to 2. So only 2 can be possible in an orbital. This also you have to write. The maximum number of electrons in each and every orbital is 2. How it can be accommodated? See, for example, one electron is like this. It is rotating. It is spinning like this, plus of rotation. Another electron which is paired up with it, it can rotate the minus of rotation. It can spin like that. So these two can be paired up. Understood? So it forms, as a whole, it forms a spherical shape. The energy of this is a spherical shape. So you don't think electron as a particle alone. It is just an energy. Okay, like a wave, spreading a wave or energy. So first plus of rotation of electron, it is now paired up with the negative rotation, minus half rotation of the second electron. These two can be paired. Okay, so in basically chemistry, you can show up this particular orbital as like this. So plus of rotation and minus of rotation. You might have seen in this in your book. Okay, so what about these two electrons? Do you agree with me? Now how many number of electrons are present? In one orbital is 2. Understood? Then we'll think about p level. P level, there are 6 number of electrons. So I said it is 2 electrons in each and every orbital. P also orbital. Then how it can be accommodated by 6 electrons? So that is the challenge. So these are all, invented by the scientists in different period. So P level consists of 2 sublevel. So one is S level. This yellow is S level. This pink is P level. Understood, ma? So this talk about the energy level. For example, if I am telling, so this graphical representation. Okay. So this is first energy level. 13.6 electron volt. This is second energy level, 14.7 electron volt. Like this, understood? So suppose if it is 13.72, then it will be here. Understood or not? Different energy levels. Clear? Different energy levels.
அப்பான்ட்டாங்க
Right.
நான் ஒரே நிமிஷம் அப்பான்னு பார்த்துட்டு இருந்தேன்.
So is it clear for you? Different energy levels. What about this one? This talk about the energy. How much energy is there? Like a wave, there are two levels, right? What is the level? S level
P.
and P level. So this yellow color, I'm just going to differentiate about all the levels. This thing you have to understand properly, so that you can teach like Feynman. Feynman technique you can use, and then you can teach your friends. Okay, so that it will be in your long-term memory. Okay, so what about this P level?
P level.
So this P level, so how many number of electrons can be accommodated in P level? I said 6 electrons. How the 6 electrons will be like? Suppose if you are drawing here, so like this, x axis, y axis and z axis, if you are considering, okay, that means in 3 dimensions. So you are just going to consider an orbital as 3D. Clear? So that means along x axis, along y axis and along z axis. So it's an orientation. It talks about the orientation of an orbital. P orbital as a whole, it is P orbital, but it can be existing in 3 orientation, 3 positions, or we can say, okay, it is arranged as Px, Py and Pz. Clear? Okay, how it can be arranged? I have told you, no, how many number of electrons can be accommodated in it?
6.
6 number of electrons. So Px level, Py level, Pz level. Only 2 electrons is the maximum number of electrons in each and every orbital. How it can be arranged? As I have told you, first one is spherical in nature. S level is spherical in nature. This P level is dumbbell. What is it called? Dumbbell. That means it is like, so plus of rotation, minus of rotation. Like this. See, for example, first of all, you have to see the S level energy. In the first S level, since it is very much closer to the nucleus, its energy is very much low when compared to second level, third level, fourth level. The electron cannot flow or cannot move in a greater velocity, greater speed. Okay, it can move very small velocity. Since it is very near to the nucleus, right? In nucleus, which energy is there? Which charge is there? Positive charge. What about the charge of electron?
Negative.
What about the opposite charges will do?
Neutral.
It will attract.
Oh.
Neutral, okay, it will attract, right? So nucleus might attract this particular electron, so that the electron cannot move speedily. For example, so always S level electrons are definitely with low energy. So even 1s level is very low, so that it is moving like very low energy. So it is forming a spherical shape. So half semicircle, half semicircle. Then if you talk about the dumbbell shape, it should be like this. So that the plus of electron will be, the plus of rotation of one electron will be like this. It is moving with light speed. Understood or not? புரியுதா? புரியல. தமிழ்ல சொல்றேன். இப்போ சப்போஸ் வந்து ஒரு நீங்க S லெவல் எடுத்துக்கிறீங்க. S லெவல் எப்படி இருக்கும்? S லெவல்ல 2 எலக்ட்ரான்ஸ் இருக்குன்னு பார்த்தோம். அந்த 2 எலக்ட்ரான்ஸோட எனர்ஜி எப்படி இருக்கும்?
Low.
கொஞ்சம் லோவா இருக்கும். அப்ப ஃபர்ஸ்ட் எலக்ட்ரான் இப்படி ஃபர்ஸ்ட் எலக்ட்ரான் என்ன பண்ணுது? ஃபர்ஸ்ட் ஹாஃப் ரொட்டேஷன் போகுது. அப்ப அது வந்து ஒரு செமி சர்க்கிள் மாதிரி இருக்கு. செகண்ட் எலக்ட்ரான் நெகட்டிவ் ஹாஃப் ரொட்டேஷன்ல போகும். இது பாசிட்டிவ் ஹாஃப் ரொட்டேஷன் போகும்போது இது நெகட்டிவ் ஹாஃப் ரொட்டேஷன்ல போகும். அப்பதான் அது ரெண்டும் பேர் அப் ஆகும். சோ அப்ப இது வந்து இட் லுக்ஸ் லைக் a spherical. P லெவல்ல எப்படி இருக்கும்?
3 dimension.
அது பார்த்துட்டோம். பட் டம்பல் ஷேப் நான் சொல்றேன். அப்ப p லெவல்ல இன்னும் கொஞ்சம் கூட எப்படி இருக்கும்? எனர்ஜி இஸ் கிரேட். ஏன்னா இது செகண்ட் ஆர்பிட்டுக்கு போயிடுது. ஃபர்ஸ்ட் ஆர்பிட்ல p கிடையாது. செகண்ட் ஆர்பிட் போயிடுது.
அட்ராக்ஷன் கம்மியா.
அட்ராக்ஷன் கொஞ்சம் கம்மியா இருக்கும். அப்ப ஸ்பீட் கொஞ்சம் ஜாஸ்தியாகும். அப்ப இது எப்படி இருக்கும்? இந்த மாதிரி இருக்கும். டம்பல் ஷேப்ல. சோ இது வந்து பிளஸ் ஆஃப் ரொட்டேஷன் ஆஃப் an electron, one electron. இது மைனஸ் ஆஃப் ரொட்டேஷன் ஆஃப் another electron. p இது x ஆக்சிஸ்ல. p இது y ஆக்சிஸ்ல இருக்கலாமா? So along x axis 2 electrons, along y axis 2 electrons, along z axis 2 electrons. அப்ப டோட்டலி எவ்வளவு நம்பர் ஆஃப் எலக்ட்ரான்ஸ் இருக்கு? 6 நம்பர் ஆஃப் எலக்ட்ரான்ஸ் இருக்கு. இது நீங்க யூசுவலாவே if you tie a stone in a thread, then நீ அத அப்படியே வந்து நீ ரொம்ப ஸ்லோ ஸ்பீட்ல இப்படி ரிவால்வ் பண்ணனா it follows very little circle இல்ல? பாத்துக்கீங்க சர்க்கிளா ஃபாலோ பண்ணும். அது இது ரொம்ப ஸ்பீட் போக எலிப்டிக்கலா தெரியும் உங்களுக்கு. இது ரொம்ப ஸ்பீட் போச்சுனா அப்படியே லூப் மாதிரி தெரியும். புரியுதா? நீ ரொட்டேட் பண்ணிட்டே இருக்க. ஃபர்ஸ்ட் சர்க்குலரா தெரியும். அப்புறம் எலிப்டிக்கலா போகும். ஸ்பீட் இன்க்ரீஸ் ஆச்சுனா அப்புறம் லூப் மாதிரி ரொம்ப ஷார்ப்பா போகும். ஓகே, அதுதான் இங்க. The same. Clear? So p level how many number of electrons? It is cleared right now, right? Then d level எடுத்தீங்கன்னா it just goes on like that. d level பத்தி அப்புறமா நான் எக்ஸ்பிளைன் பண்றேன். பட் d levelல how many number of electrons? 10 electrons. So 5 different orbitals இருக்கும். f levelல 14 electrons இருக்கும். Okay, I'm coming to the element. We are talking about calcium, for example. What is the atomic number for calcium? What is the atomic number for calcium? This is p level.
20.
Yes, level.
20.
Okay. See, for example, in the third orbit, 3 levels are there. Okay. So, what about the 3 levels? S, P, D. This is for third orbit. I'm just changing the color for mentioning the 3 orbital. In the third orbit, how many orbitals? S, P and D. Clear? In fourth orbit, it will be S, P, D, F. Like that it will be. Clear?
Yes.
Okay. Now we will coming into this calcium. Calcium consists of 20 number of electrons. Okay. If that is 20 number of electrons, what is meant by octet configuration? You don't know? The atom has its own stability. You are also having your own stability. How do you work? By head?
Like
So that is your stability. Clear? Like a atom also having its own stability. It should contain 8 number of electrons in its outermost orbit. Then only it will be stable. Unless otherwise it won't be stable. God didn't create every atom as a stable one. If we create everything as a stable one, then it won't be reacted with some other atoms. It might be inert. What are all the inert gases in your periodic table? That is not specifically that. How come hydrogen will be an inert gas? It's not an inert gas. Argon, xenon, krypton, everything you must know. Okay. So why we are used to call that as an inert element? It won't mingle with some other atoms. Why? It has 8 number of electrons in its outermost orbit.
neon.
Yeah, neon, krypton, argon, xenon, so many things. Okay. So that is the last group elements. It is given in your book, right?
Helium.
Okay. So what about we are going to learn? What about we are going to learn? The inertness or the stability of an atom. Okay. So it talks about the stability. What is the stability? The outermost electron, the outermost orbit should be filled with 8 number of electrons. If it is 4 number of electrons, that is it will be half filled. That is also stable. Carbon is stable, for example. Okay. Then if it is less than half filled, more than half filled, then that won't be existing as an atom. It may be lose or gain electrons, so that the atom becomes ions. Understood? Take a note. Maybe first we'll finish within 5 minutes. Okay, the atoms tends to lose electron. if its outermost orbital, if its outermost orbit contains less than half filled, or outermost orbit means that is the valence orbit, valence shell. Okay, valence shell should contain less than half filled. That means what it will be? Less than 4. Clear? Less than 4. Then that type of atom is known as positive ion. So how many atoms, how many electron can be lost by an atom? Maximum how many number of electrons can be lost? I told you less than 4. Okay, if the outermost orbit of an atom contains 1 electron, then it can able to lose 1 electron. Okay, for losing of 1 electron also atom needs energy. Atom requires energy to lose an electron. So that type of energy is known as ionization energy. Okay, if atom lose 1 electron, it will be right now proton rich. It lost 1 electron, right? So it will be proton rich. Clear or not? Why we are used to call that? There are equal number of protons and electrons. Understood or not? Okay? If there is one electron deficiency, then this proton is said to be rich manner. So it is known as positive ion. That positive ion is known as cation. Clear? So what you have to say was what is positive ion in this? The atom tends to lose 1 electron. Okay. Yeah, he'll be coming within 2 minutes, 5 minutes. Okay. So the atom tends to lose electron from its outermost orbit. How it may lose electron?
Energy.
If the outermost orbit is filled by less than half filled electrons. So now tell me how many electrons can be lost by an atom?
2.
Only 2? Either 1, either 2 or 3. Less than 4. Until 3 it can lose. So aluminum is the greatest example. Aluminum can lose 3 electrons. So it will become aluminum 3 plus. Copper can lose 2 electrons. So it is copper 2 plus. Okay, sodium can lose 1 electron. So it is. So all these are metals. Okay. So metal can be electropositive. Metals are electropositive, good conductors of electricity, that and all we will see. Okay, so this is nothing but cation. What is it called? Cation. Write the opposite of this. Atoms. Write the opposite. Atoms tends to gain electron. Atoms tends to gain electrons if its outermost orbit contains more than half filled. If its outermost orbit contains more than half filled. If its outermost orbit contains more than half filled. If it is more than half filled, then what will happen? The atom gains electron. Very good. So that is also done by 1 by 1. Okay. So for that also atom requires energy. Atom requires energy to gain electron. So that type of energy is known as electron gain enthalpy. Okay. So there are lot more things to learn about this atomic structure. Okay. Then what I told you that okay, now the atom becomes negative ion because it is gaining electron. Anion. It is gaining electron. So electron is rich now in an atom. If it is an atom should contain equal number of protons and electrons. If proton is rich, then it is known as electropositive or cation. If electron is rich, then definitely anion or negatively charged ion. Is it clear for you?
Yes.
So these two ions are formed right now. I am coming to the valency. What is an octet configuration? We write for calcium, right? What is the octet configuration? How many number of electrons can be accommodated in the first orbit? 2. In the second orbit?
6.
8. 2s2, 2p6. 8. Third orbit?
16.
No. 18.
18 is the maximum possibility. Maximum availability of electrons. Okay.
12.
So what is the remaining here?
Okay. 10.
10. But you don't write 10 like. So for an octet configuration, you should write after 2, 8, 8, 8. Why after 2? Because there is a possibility of number of electrons in the first orbit is 2 alone, not more than that. So first orbit is an exemption. You can't write 8. So that the hydrogen is not an inert gas. Understood?
Yes.
Okay. Helium also we don't consider as inert. Okay, I am coming to that point. So 8 number of electrons should be what is the inert gas or inert thing? It should contain 8 number of electrons in its outermost orbit. So that the second orbit is the possible orbit for a inert gases. Understood? So hydrogen and helium are exemption for this. Okay?
So helium is not inert.
So it can mingle with. Okay? So hydrogen also mingle with. So I am talking about all these things because these atoms, by looking at this particular configuration, only how the atoms are combined together in different bondings. There are two major bondings, electrovalent or ionic bondings, then covalent bondings. Two bondings. It leads to two different vast branch. Covalent bonding, it is organic chemistry. Electrovalent or ionic bonding, it is inorganic chemistry. So it is a very different field, vast field. Okay, based on this bonding only. It's really amazing fact. Okay, so for calcium, can we write like this? So what is the outermost orbit? 2. Okay, how many orbits are here right now? If you take it,
20.
no more. First,
4,
second,
4.
you are saying 4, right? But for calcium, only 3 orbits are there. It's a problem. It's a hypothetical.
So it
Okay.
loses the 2.
No. That I am coming to the point. So octet by means of octet configuration, you can easily find the valency by writing first orbit as 2, second orbit 8, third orbit 8. You can distribute the number of electrons 8, 8, 8, 8 after the first level. And then what is the remaining? You can write at the last. Then that will be the valency. By calculating the valency, that is okay. But it is hypothetical when you look upon the orbit side. So that you must understand what is it actually octet configuration. Octet configuration means it talks about the stability of an atom. Okay, the outermost orbit should contain 8 number of electrons in order to maintain its stability. That is octet configuration. Okay, by looking at it, we used to call this as valency. That is okay. Okay, but it is deviating from it, or it may violate. Right? What is the orbit? Number of orbits for calcium will be only 3 orbits. So according to orbit level, how can we express this?
2 is the valency.
Yeah, 2 is the valency. According to orbit level, how can we express this? I will explain you with the electronic configuration. So electronic configuration is different, and then it is very particular about the calcium's valence. What is the electronic configuration? I have told you in S level, L, right? N and L you have seen. Okay? K level, L level, M shell, N shell. Right that? Clear or not? So 2, 8, 18 and 32. What is L level? So S level, P level, D level, F level. So for the S value it is 0, for the P value it is 1, D value is 2 and F value is 3. And then you know number of electrons. 2 electrons, 6 electrons, you know, right? 2,
6, 10.
6, 10 and 14. Clear? This is value of L. This is number of electrons. Understood, ma? Based on this, we can able to write the electronic configuration. So what about this 2 electrons? It lies in first orbit, right, ma?
Yes.
It lies in first orbit, S level. How many number of electrons can be? 2 number of electrons. So this talks about N value. N is orbit, right? This talks about L value. L is orbital. Do you know the difference between these two? புரியலையா? ஆர்பிட்ன்றது என்னது?
The path.
அதுதான் imaginary path, first path, principal quantum number n அப்படினு டெசிக்னேட் பண்ணிருக்கு இந்த லெட்டர். Okay, then what about orbital?
The electron.
Orbital means sublevels. I have drawn the sublevel, energy sublevel. Clear? So what about the sublevel? It is designated by letter L, right? Orbital level. Purida?
Yes.
So then this 2 talks about the number of electrons. Likewise, we need to write for all the orbits. So 20 electrons of calcium can be distributed like this. Then 2. In 2, how many orbitals are possible in the second orbit? How many orbitals are possible? எவ்வளவு orbit நம்ம draw பண்ணிருக்கோம்?
6.
நீ number of electrons யும் orbital யும் confuse பண்ண கூடாது.
8.
டேய் எவ்வளவு orbital டா இருக்கு?
4.
What is this? S and P. எவ்வளவு orbital இருக்கு செகண்ட் ஆர்பிட்ல?
Oh, 2.
2 orbital. புரியுதா இப்ப? ஃபர்ஸ்ட் ஆர்பிட்ல ஒரே ஒரு லெவல் மட்டும் தான் இருக்க முடியும். செகண்ட் ஆர்பிட்ல ரெண்டு லெவல் இருக்கு.
Third. 3.
யா. சோ அப்ப செகண்ட் ஆர்பிட்ல எப்படி இருக்கும்? 2s 2 2p ல எவ்வளவு இருக்கணும்? 6 இருக்கணும். Clear or not?
Yes.
Then children, if you learn along with me, then it is very easy for you. Then what about the next one? Third level ல 3s2 3p6 வந்துருமா? அடுத்து என்ன வரணும்? 3d வரணுமா? spd வரணும்ல. fourth level எப்படி வரும்?
3D 10.
SPD.
இல்ல என்னலாம் இருக்கும்? 1s2 இருக்கு, 2s2 2p6 இருக்கு, அப்புறம் 3s2 3p6 3d 10 வரணும், அப்புறம் 4s2 4p6 4d 14 10 sorry, அப்புறம் 4f14 இப்படி வரணுமா? சோ இதுல நான் சொல்றேன் எதனால இது ஃபில் ஆகல அப்படி நான் சொல்றேன். இதுதான் ப்ரொசீஜரா வரணும் இல்ல? It should be coming like this. Then it is following some n plus l rule they are saying. What is the n plus l rule? That means there are so many scientists, they have invented Hund's rule like that. So Hund he predicts some rule by observing the atomic structure. It is there. It is already there. He is not creating any rule. He is not controlling the nature. He just observed the nature, observed an atomic structure, and he predicted a rule. What is that rule called? Hund's rule. He put his name. I have told you already, for their content purpose, for their pattern. So they put their own name. Okay. So Hund's rule, it states that electrons are filled in an atomic orbits in an increasing order of energy level. So the energy level, first lower energy level is filled up, and then higher energy level, and then higher energy level. So from the increasing order of energy levels, it should be filled up. Understood? So we are going to find about this n plus l rule means it is showing the energy levels. Okay. So what is for suppose what has to come? The original electronic configuration is after 3p it is coming like 4s. After 3p what is coming? 4s is coming instead of 3d. Okay, I will show you why. Okay, so what is 3d and 4s? What is 3d? What is the n value for 3d? Do listen properly. What is the n value for 3d?
N value. 2. No.
N. What is n value? ஒரு பழமொழி சொல்லுவாங்க தமிழ்ல, விடிய விடிய கதை கேட்டு.
மேம் இல்ல மேம் இது வரைக்கும் புரிஞ்சது.
அப்ப நீங்க physically present. That's why the reason.
இல்ல மேம் இது 4s2 அதுக்கு அப்புறம் ஏன் 3pd வரல?
Yeah, that's what I'm saying. N plus l rule. I've taught you what is n, what is l. What is n here? Which letter?
1. Sorry.
1. What is n here? In 3d? 3. What is l?
D.
L value for D. D correct. D is L. What is L value for D?
2.
So 5. What is n plus l value for 4s?
4 plus
Anisha is having lot of store in your brain, but you are not using it.
4 plus
2.
4 plus 2 மண்டல கொட்றேன் பாரு.
4 plus 10 na.
Huh? How it will be 10?
No.
What is 4s? S value, just see.
4 plus 1 5.
S value.
No, 4.
4 plus 0. Right? So that is equal to 4. So which one is greater?
5 3D.
3D. So 3D is greater than 5D. Sorry, 4s. Right?
Yes.
So which one is filled first? The lower level is filled first. So 4s comes first and then 3D. Clear? After 3D may not be coming. Due to this N plus L rule, 4s level is, the energy of the 4s level is lesser than the energy of the 3D level. That is the reason. Take a note of this.
3D is greater than 4s.
Yeah. The 4s level is lesser than the energy of 4s level. The energy of 4s level is less than the energy of 3D level. Okay. So that 4s filled first according to Hahne's rule. Based on the increasing order of energy level, the electrons are filled. So 4s comes first and then 3D. So this is the meaning. Is it clear for you now?
Yes, ma'am.
Understood?
Yes, ma'am.
So fourth orbit like this, like that, the fourth orbit comes. Clear? So what is the valency now, ma? The outermost orbit, the number of electrons present in the outermost orbit.
4 plus
2.
2.
oh,
This is electron,
yes,
right?
Yes.
Okay, so listen carefully. This is number of electrons. So how many number of electrons are there?
2.
2. So you can write octet configuration as well as electronic configuration for calculating the valency of a particular atom or element. Clear? This is very easy. By writing octet configuration, it's very easy. But in detail, you have to experience this kind of electronic configuration. It shows in detail. Okay. Right now, if you practice with this electronic configuration, then it is easy for you to learn for your higher classes. Got it? So take it as an assignment. What are the assignments I gave? Do you remember?
Check the Google
Yeah.
for examples of
Isobar.
Examples of
isobar.
Isotope.
Isotopes, isobars, and isotopes. And next assignment, you can add in your periodic table right from the first element to iron. Right from 1 to iron. Or
29.
Copper is 29. Okay. Until copper you can write.
Valency, ma'am.
Valency by writing both octet configuration and electronic configuration.
Yes.
So you should write both octet, electronic configuration and valency. Okay? Write and come, then I will explain you the remaining the next class. Thank you.